Welcome to the lesson on using calculators to solve real-world integer problems. We're going to again be using the STAR method when we look at the word problems. But first, let's review or look at a few pieces of information that might help you with these word problems. First, we want to remember what an integer is. It's any of the natural numbers, which those are the ones you learned to count by: 1, 2, 3, 4. The negatives of these numbers, such as -4, -3, -2, -1, and then 0. Put all that together and you have all of the integers. Integers can be represented by a number line. In the middle of a number line, we usually put 0. 0 is neither positive nor negative. To the right are the positive integers, and to the left are the negative integers. Now that's just a review of integers represented on a number line. Another thing to think about is different ways to think about positives and negative integers. One of the ways in the real world that we use these positives and negatives is when we're talking about elevation. So just looking at how things are measured, where they are located on the earth. So if you look right here at this definition, an average level of the surface of one or more of the Earth's oceans from which heights such as elevation may be measured is called sea level. So at sea level, we would say we have an elevation of 0. Anything above sea level, like Mount Everest, would be represented by a positive integer, and anything below that sea level in altitude and elevation, so like the Dead Sea, would be represented by a negative number. Another way that we use integers in everyday life is through the thermometer, looking at numbers such as this right here, which is 6 degrees Celsius, and then this right here, which is at -6 degrees Celsius. Now I showed you this world map right here to let you see that everything in blue are countries that use Celsius as the unit of measure for temperature, and in the red is Fahrenheit. And as you can see, only the United States of America, you have Alaska with it, use the Fahrenheit system to measure temperature. Everywhere else use Celsius. Again, in measurement, same thing. Everywhere else uses a metric system, and here in the United States, we just use the standard system of feet, inches, that kind of thing. But Celsius is just one of the ways Mr. Fahrenheit used the Fahrenheit method to look at temperatures, and then later there came along Celsius, and Celsius was more understandable and easier to use for the world. For the most of the world agreed that it was, and so that's why they put everything in Celsius. So if you went to another country, you're going to see a different degree measure. So if they say it's 6 degrees Celsius somewhere else, don't think of it as 6 degrees like we would think about here. You would have to use a conversion, which you can get one on your phone or whatever. But that's just another example of something using positive and negative integers. Another thing uses positives and negatives is credits and debits when it comes to money. When you deposit money into your bank account or into a piggy bank, it's a positive number represented by a positive integer. But when you withdraw money from your piggy bank, see the hammer about to go right on the pig, then that's going to be represented by a negative integer. Another thing that is used in everyday life that uses positives and negatives is actually time. So you may be studying something in history that happens in the BC or before Christ era, and those are represented by negative numbers, or they could be in AD and be represented by positive numbers. So between 60 BC and 40 AD, it was actually 100 years between those two. But BC is represented by a negative integer and AD by a positive integer. So here's an example of a problem. Again, we want to begin by search. If it is 25 degrees Fahrenheit and the temperature drops 34 degrees over the next several hours, what is the temperature now? Okay, so it is 25 degrees. The temperature drops 34 degrees over the next several hours. What is the temperature now? Of course, it's 25 degrees Fahrenheit. This is a crazy question. Let's mark out that now and change their question that I got this off of. What is the temperature going to be in several hours? So that would make more sense with this question. So we're going to begin at 25 degrees, and again we're saying Fahrenheit, and then the temperature is going to drop, so it's going to go down 34 degrees. Another way to write this is 25 plus negative 34, but you can write it either way, and that is our translate. So we're going to translate our problem using the operation of subtraction because it's dropping. Either one of these you put in a calculator because we are using those. 25 minus 34 is negative 9 degrees Fahrenheit. So after several hours, the temperature now is 25 degrees. It's going to drop 34 over the next several hours. What's the temperature going to be? We answered the problem right here with our negative 9 degree Fahrenheit. Then we're going to review that. If we're at 25 degrees and we drop 25, we'd be down to 0. But we're going to go even past that because we're going to drop more than 25 degrees, so we will be in the negatives. And so that answer looks reasonable. It's negative 9 degrees Fahrenheit. Now here's another one, and again we are going to search the problem. A deep sea diver is currently at 200 feet below sea level and is expected to fall 30 feet each minute for the next 5 minutes. Where will he be located at the end of the 5 minutes? We looked just before at sea level. So if we have sea level here, maybe I should have put that in blue. And he starts down here at negative 200, so that's going to be below the water. And he's expected to fall 30 feet each minute for the next 5 minutes. So he's going to go down 30 more every minute for 5 minutes. So I can translate my problem. We're going to begin at negative 200, or 200 below sea level. We're going to take away 30 feet more every 5 minutes. You can put this in your calculator and you can put all of this right in the calculator. Negative 200 minus 30 times 5. It's negative 200 minus 150 if I'm working it out without a calculator. So now it's at negative 350. Or we can write that as 300, maybe put that in a different color, 350 feet below sea level. Now I can write that with my negative here, or I can say feet below. That takes care of the negative if I write it in words. So now this deep sea diver is now 350 feet below sea level. Okay, let's go back to that one. Looks like I forgot some things, right? So here's our answer. We got negative 350. We rewrote our answer using the words below sea level. Is that reasonable? Or R? Well, if he starts at 200 feet below sea level and is going to drop 30 feet over the next 5 each minute for 5 minutes, so we're going to go down, 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 down. That's going to put him below 250, so 350, negative 350 is below negative 200, so he's going down deeper into the ocean. That is reasonable answer, and so I'm probably okay with that. I also can double check my calculations to do whether it's reasonable and just review my answer. Okay, so the average yearly temperature in California is 64 degrees. And in Antarctica, it's negative 49 degrees. What is the difference in these average temperatures? Well, we would need the difference between them, and I'm going to use a number line to kind of look at this. I'm going to put 0 in the center. 64 is over here in the positive rim of things, and negative 49 is down here. So I have searched it. I'm translating it using a number line. The difference in these average temperatures is how far apart are these numbers, 64 and negative 49. Well, between here and here is 49. Then up through here is an additional 64. So 49 plus 64 will give me 113. That's 113 degrees apart. That is one way to translate it. Another way is to take 64 and subtract the negative 49, knowing that the word difference can be represented by subtraction. And if you put that in a calculator, 64 subtract negative 49, it's going to give you positive 113. So you can use the number line to translate it, or we can use the difference and just use a math using subtraction. But this is our answer, and we're going to review that and see if it's reasonable. So we review that and we look over it. If the temperature, again, is 64 in California, negative 49, they're more than 64 apart because they got to go over that 0. And 64 is close to 60. 49 is close to 50, and 60 plus 50 is 110. So that makes that reviewing it makes it a reasonable answer. We're not far off from what I just did there, which is estimate my answer. So we're good with that one as well. All right, Confucius. He said a lot of little sayings that people say today. He was born in 551 BC, and Abraham Lincoln was born in 1809 AD. He was our 16th president, and he was assassinated. How many years apart were they born? So we're going to look at these two, and again, we can use a number line to look at this problem, but I've searched it. And remember, we're at 0, and down here we would represent BC by a negative number. ADs are represented by a positive number. Or the words BC itself let us know that it's before Christ, before that time change over into AD. So this is at negative 551, and this is at 1809. And again, how many years apart were they born? Well, from here up to here was 551 years. And from here up to here is 1,809 years. So how far apart are these numbers? Again, when I translate it, I can do so with my number line I just showed. I could take 1809 and subtract negative 551, or I can see how far it is to 0 and then how far above 0 it is. Both of these ways, it will end up that I'll need to add them. So they were born 2,360 years apart. So 1809 is a good 1,800 years past the changeover to AD. The negative 551 is close to about 500. That would be 2,300 years apart. That's close to my answer. So that was my answer, and then I reviewed it. I could review my math, make sure I added it up right or put it in the calculator correctly. And so the two were born 2,360 years apart. And one more. A local business made a profit of $1,000 their first day open for business. So they made a profit. Getting a profit is a positive thing. And I am searching the problem. Their first day, they were open for business. For the next 3 days, though, they had $500 loss each day. So I can represent a loss by a negative integer. What integer would represent their status at the end of the 3 days of loss? So their first day, they were at a 1,000. I'm translating this. Then they went down or lost $500 for the next 3 days. So one thing I can do is I could say 500, down 500 for 3 days and use that. I could do 1,000, take away 500 for the first day, 500 the second day, 500 the third day. So although this business started out doing well, they now are at negative 500, or they are in the hole after the next 3 days happen. So the fourth day in, this is the first day, then three days after that, they lost. So they're in the negative. This is my answer. I'm going to review it. Would they really be in the hole? Yes, they have lost more than they gained that first day. My answer, I review it. I can redo the math here. I can check things in my calculator, but it will be that they lost or went down $500 after those 3 days where they lost 500 each day. So those are just some more word problems that we're looking at using the STAR method. This time we're working with integers, things that are represented by positive and negative whole numbers. You have a couple of sheets that give you some problems to use to work on. You also have a game in between those two sheets for this lesson. So that's all for now. Thank you.